In the last lesson, we introduced the idea of exponents. In this section, we're going to talk about the closely related topic of radicals. So let's start off with a definition. Let n greater than 0 be an integer and a be an expression. It could be a number, but it doesn't have to be. The nth root of a is denoted b, which is denoted by this symbol right here. This number b is an expression such that b to the n equals a. And the number n is what we call the index. Now, when a is a real number, then this symbol we call the principal nth root of a. And so let's define what we mean by that. So if a is greater than 0, then the nth root of a is the positive number b, such that b to the n equals a. Now notice we're only restricting ourselves there to positive numbers. We're not allowing this nth root to be negative. Now if a is less than 0 and n is odd, then the nth root of a is the negative number b, such that b to the n equals a. And then a third case, well, if a is less than 0 and n is even, well, then the nth root of a is not a real number at all. So a couple simple examples that illustrate this. If we take the square root of 16, that equals positive 4, and that's true because 4 is a positive number such that when you square it, you get 16. Now notice that we don't say the square root of 16 is plus or minus 4, and that's because we're dealing with the principal square root of 16, so it's by definition the positive number 4. The cube root of negative 8 is negative 2, and that's true because negative 2 cubed equals negative 8. Alright, so now let's move on a little bit and define what we call rational exponents. Remember, a rational number is like a fraction. And so there's going to be two parts to our definition. First, we're going to define a raised to the number 1 over n. And that is simply another notation for the nth root of a. So there's really nothing new here in this definition. It's just a different symbol, different notation. In the second part of this, we're going to extend the first part, a raised to the m over n, where m and n are both integers. And a to the m over n, there's lots of different ways we could define that. One way to define it is as the nth root of a raised to the mth power. Or, stated another way, a to the 1 over n raised to the mth power. Okay. A third way that we could define this as the nth root of a to the m. Or, using the first part of our definition, we could write this as a to the m raised to the 1 over n power. So we see that rational exponents are defined in terms of these radicals that we just defined, and they're defined in terms of exponents like what we talked about in the previous section. So all those properties of exponents apply to rational exponents as well. And so let's do some examples here of simplifying expressions dealing with rational exponents. So here we've got this expression as the square root of 16x squared y to the 8th z to the 4th. And usually it's easier to work with radicals in terms of their exponent equivalent. So we could write this as 16x squared y to the 8th z to the 4th power, and then all that raised to the 1/2 power. Okay. And so now when dealing with powers, we can use our properties of exponents. We'll just distribute that 1/2 to each term. So we've got 16 to the 1/2 power, x squared to the 1/2 power, y to the 8th raised to the 1/2 power, z to the 4th raised to the 1/2 power. Okay. And now we can start using properties of exponents to calculate these. The square root of 16 is 4. Now we've got a power to a power here, so 2 times 1/2 is going to be 1, so x to the first power. Likewise here, 8 times 1/2 is going to be 4, and then 4 times 1/2 is going to be 2. And so here's our simplified equivalent expression. Here's another example that will illustrate how we can use properties of exponents to simplify rational exponents. And so let's first write this as 3a squared b cubed raised to the 1/2 power, and then 6a to the 5th b raised to the 1/2 power. Okay, so now notice what we have here is something times something else, and both of those somethings are raised to the same power, which is 1/2. So what I can do is take this underneath, combine both those expressions and put them underneath just one exponent. So we can take 3a squared b cubed and then times 6a to the 5th b, and then raise all this to the 1/2 power. And so now underneath that power we can simplify things. 3 times 6 is 18. A squared times a to the 5th, that's going to be a to the 7th, and then b to the 4th power, and then this is all to the 1/2 power. And now we can, there's several ways we could rewrite it from here, but for right now let's just write it in this form: 18a to the 7th, b to the 4th, and we'll take the square root of that. Here in a minute we'll talk more about how we could simplify that some more, but for right now we'll just leave it in that form.